Hello students, we are going to start a new chapter, circles. This is the 10th chapter of grade 10th. You have studied about circles a lot. You have studied about circles in your initial classes, right? And also seen circular objects all around. Your favorite pizza. This is a circle, and let me mark the center of the circle. This is C, the center of the circle. This is any point on the circle. Let me mark as A, right? So, the circle is a collection of all the points. These are the points, the collection of all the points in a plane which are at constant distance from a fixed point. This is called the center of the circle. So, and the fixed distance is called, CA is called the radius of the circle. So, a circle is a collection of all the points in a plane which are at a constant distance from the fixed point. So, let us move forward. What are the parts of the circle what we need to study? These are the parts of the circle we have already studied. This is the center. Let me mark as O. O is the center of the circle, and let me mark as P and Q. These are the 2 points on the circle. So, what is the diameter of the circle? This is PQ. The 2 points, the end points are P and Q, and it is passing through one fixed point, that is the center O. So, diameter is a line segment joining the end points of the circle and passing through the center of the circle, and this is the radius. Let me mark this as R. So, what is the radius? Radius is OR, the fixed distance from the center to the circle. This is the radius. These are the 3 points what we have studied in our initial classes. We will move forward. We will see the relationship between a line and a circle. Here we see a line and this is a circle. Here the line and the circle are not intersecting. They are wide apart. They are not touching each other. So, this is case 1, wherein we have 0 point of contact. Now, as the line move forward, we have the line is touching the circle. The line is touching the circle at one point. Let me name this as P. This point is point of contact of the line and the circle, and then as we move forward, we move the point inside the circle. Then we have 2 points of contact, that is P and Q. We have 2 points of contact of the circle. So, what we find? The relation between the line and the circle, we have 3 cases. The first case, non-intersecting. The line is not intersecting the circle, right? The second case, the line is intersecting the circle only once. We have this as a tangent. This is a tangent wherein the line PQ is intersecting the circle at one point A. At one point A. Now, as we move forward, we have 2 intersecting points. The points are A and B, and this is called a secant. There is some difference between a secant and a chord. This is a circle, and let me mark 2 points P and Q. Then PQ is a chord. This is a chord, and there is a difference between a chord and a secant. What is the difference? Secant is a line. You can see this, 2 arrows. So, secant is a line, whereas a chord is a line segment. Chord is a part of a secant. It is not a secant, it is a part of a secant. So, we find a difference between a chord and a secant. But now, we are going to study about tangents, right? What is a tangent? This is a circle and a point O. We have a line, let me name this as X and Y. This XY is touching the circle at a point P, right? And what are the number of contacts? 1. The point of contact is 1. The word tangent comes from the word tangere, which means to touch. It is touching the circle, right? And was introduced by the Danish mathematician Thomas Finnecke in 1853. Remember this. And then a tangent, what is a tangent? Definition of the tangent. The tangent to a circle is a line that intersects the circle at only one point. At only one point, this is named as P. So, number of tangents, how many tangents can you draw from one point? Number of tangents from one point of the circle. Here is the one point P. This is one point on the circle, right? You can see how many lines. So many lines can be drawn from this one point. So many lines can be drawn. Now, this is another line, one line, this is the second line, this is the third line, this is the fourth line. How many lines can you? A number of lines, right? Now, we can see that this line has 2 points on the circle. Again, number 2 line, this has 2 points on the circle. But if we see line number 4, how many point of contact? Only one. So, how many tangents can you draw? Only one. The tangent to a circle is a special type of a secant. This is a secant and the end points coincide. The end points are coinciding with each other and they form a tangent. So, there is only one tangent at the point on the circle, one tangent. This is one tangent. Let me name as P and Q. So, we have only one tangent. So, the common point of the tangent and the circle. This is a circle. We have center O of the circle and this is a tangent. Let me name this as X and Y. What is P? It is a point wherein the circle and the tangent are touching. So, the common point of the tangent and the circle is called the point of contact. It is called the point of contact and the tangent is said to touch the circle. Here it is just touching the circle. See, here is touching the circle at the common point. So, P is the common point of the tangent and the circle and is called the point of contact. This is theorem 10.1. The tangent at any point of the circle is perpendicular to the radius through the point of contact. This is the circle with center O, this is the center O and x, y, this is the tangent and P is the point of contact. P is the point of contact and what does the theorem say? Theorem says that OP is perpendicular to xy. OP, the radius, is perpendicular to xy, the tangent, at the point of contact P. What is this? Let us see. First, let us join OQ. What is Q? Q is any point other than P on xy. Q is any point. We can take Q here also. We can take Q here also. Any point on xy other than P. So, we have a circle with center O and a tangent xy at the point P. What we need to prove is OP is perpendicular to xy. Let us take a point Q on xy other than P and join OQ. We have joined OQ. Now, OQ is greater than OP. Why? Why is OQ greater than OP? We see that OP is the radius. So, this is also the radius, this is also the radius. Why? Radius is the distance between the center and any point on the circle. Now, again if I take any point outside the circle, like Q is any point outside the circle, then this distance OQ will be greater than the radius. OQ is greater than OP. Why? OP is the radius. So, OP is the shortest distance. Why again it is the shortest distance? Because OP is the radius and the shortest distance is always a perpendicular. So, OP is perpendicular to OQ. I hope it is clear. OP is perpendicular to OQ. We know a relation between a line and a circle. Now, we have a point and a circle. There are three cases again. We have a point inside the circle, we have a point on the circle and we have a point outside the circle. Three cases, we have a point inside the circle, on the circle, outside the circle. Let me see the first case. When we have the point inside the circle, can we draw a tangent when a point is inside the circle? We can draw a number of lines. We can draw a number of lines. But is there any tangent? No, we do not have any tangent on the circle when the point is inside the circle. Let us see the second case. The second case is when the point is on the circle. We have already studied that. How many tangents can we draw? We can draw only one tangent. We can draw as many lines as we want, but there is only one tangent. One tangent, this one. So, we have only one tangent to the circle when the point is on the circle. Let us see the case third. We have point outside the circle. How many tangents can we draw? We can draw as many points, as many lines, right? But we have only two tangents. This is one tangent and this is the second tangent. So, we have two tangents to the circle when the point is outside the circle. So, we have three cases. I hope it is clear now. What is the length of the tangent? P is a point outside the circle, and from point outside the circle we can make two tangents. PA is one tangent, PA, and PB is the second tangent, and A is a point on the circle, B is a point, another point on the circle. Again we have PA and PB as two tangents. So, what is the length of the tangent? Distance from P to A, distance from P to B, this is the length of the tangent. So, PA is the length of the tangent. In other words, PB is the length of the tangent. In words we can say the length of the segment of the tangent from the external point P and the point of contact with the circle is called the length of the tangent, right. This is the length of the tangent, this is the length of the tangent. I hope it is clear. Let us move forward to theorem 10.2. The lengths of the tangent drawn from an external point. What is an external point? P to a circle are equal. What do you mean by this? The question says PQ is equal to PR, right. P is an external point and Q and R are points of contact, wherein PQ is one tangent and PR is another tangent. So, what is given? Given is a circle with center O, a point P lying outside the circle, two tangents from the point P on the circle, and what we have to prove? We have to prove that PQ is equal to PR. The first step is let us join OP, let us join OQ and let us join OR, right. We are joining the three OP, OQ and OR. Now, this angle PQO, this angle, what is this? This is a right angle. Why? We have studied earlier. When a radius is touching this tangent, then this angle is a right angle, a 90-degree angle. This is a 90-degree angle. Similarly, angle PRO, this is again 90-degree angle. So, we have angle PQO is equal to angle PRO. These two angles are equal. Also, we know that OQ is equal to OR. Why are these two equal? Because they are the radii of the same circle, and OP is equal to OP. Again why? Because they are common. So, by RHS we have this triangle congruent to this triangle. The two triangles are congruent. Since the two triangles are congruent, we can say that PQ is equal to PR. PQ is equal to PR, and this is what we have to prove. I hope it is clear. Only one concept, that radius is making a right angle with the tangent. Only this concept you have to remember. So, I hope you have understood the concepts of this session. Please practice questions from the NCERT. Thank you.